Hello guys, how you doing? What is up? Right here, let's start at the very beginning of 7.1. This is just about what is a sampling distribution. Okay, so they go through two different examples right here of situations, and they ask you to find the population parameter and statistic. So in this case, a medical researcher is interested in exploring the effects of a new medicine on blood pressure. 500 males with high blood pressure are randomly selected and given the new drug. After 2 weeks, their blood pressure is measured and the average arterial pressure is calculated. So the population, of course, is all males. Right here is going to be all males with high blood pressure. The parameter, remember, is based on the population. So that's what you're actually finding. So we want to know the true mean, which is mu, of the arterial, sorry about that misspelling right there, it's arterial pressure of all males with high blood pressure. And the statistic, that's based on your sample. Looks like we have 500 males right here. So that's the sample mean, X bar, arterial pressure of the 500 males in the sample. Okay, for part two, number two rather. Studies get to determine whether or not the dangerous activity texting while driving is a common practice. We have 1,500 16 to 24-year-olds randomly selected and asked whether or not they text while driving. Of the 1,500 drivers, 12% indicate that they text while they drive. So the population is all 16 to 24-year-olds, right? The parameter is based on the population. So this looks like it's a proportion right here. It is one, right? So that's going to be the true proportion, which is P, of drivers who text while they drive. The statistic is based on the sample. Sample is 1,500 drivers, so that's the sample proportion, that's P hat, of the 1,500 drivers who said that they text and drive. In this case, P hat happens to equal 0.12. Okay? So there we go. All right, now we're on concept two. So right here, we were giving a situation where a breath to cereal includes marshmallow shapes. They had 10% stars, 10% crescent moons, 20% rockets, 40% asteroids, 27% planets. Interested in examining the proportion of rockets in a random sample of 2,000 marshmallows from the cereal. Sketch the population distribution. Okay, so right there, here we made it as a bar graph. All right, the relative frequencies on the Y and the actual types of marshmallows are on the X-axis right here. And I just basically used all this data right here, 10%, 10%, 20%, 40%, and 20% respectively. All right. If you want to label them, you can if you want. Okay, it's up to you. Okay, no problem. So let's go to the next one. Suppose you were to collect a random sample of 2,000 marshmallow shapes, sketch the distribution of sample data you would expect to see. How many rockets would you expect to see in your sample? No problem. Okay, so this is pretty easy to understand right here. So we're trying to go and let me show you what we're doing right here. We're figuring out, let's see, first of all, the stars. How did I get that 200? Well, to get this right here, I just said, okay, 200, it's 2,000 total shapes, right? Times the percent that we expect to see from stars, which is 0.10. So that comes out to 200. And same thing for crescent right here, 2,000 times 0.10. Rockets was 0.20, so that was, of course, 2,000 times 0.20. And that comes out to 400 right there. So that's why we got 400 right there. This astronauts was 2,000 times, and this was 0.40. So that comes out to 800. And then planets was just like rockets was 2,000 times 0.20. So as it says, how many rockets would you expect to see? Rockets is right there. We had 2,000. And they said that we had about 20% were rockets, so 0.20. And that came out to right here, 400. There we go, 400 rockets. Next. Now suppose you collect many samples of the same size, sketch the sampling distribution of the proportion of rockets you think you would see in the samples. This was a little bit difficult to do right here. And this is right here the proportion of rockets on the X-axis. I don't know why they asked this actually in this particular section. Whatever. Now, we do know actually that it is approximately normal. And how we know that, and this will come to the next section, is if we do n times p, So that's going to be 2,000. And our percentage of proportion of rockets, remember, is 0.20. So N times P is going to end up giving you 400. That's greater or equal to 10. And N times 1 minus P is right here going to be 1,600. That's also greater or equal to 10. So it's approximately normal. So we can just draw a sampling distribution right here that looks approximately normal. And again, the mean, remember, is going to be 0.20. It's because the mean of p hat is unbiased estimator p, which is 0.20. The standard deviation of p hat, we should do the 10% right here. The 10% rule, that's 2,000 less than 10% of all the marshmallows. We do know that. We'll get more of this in the next section. All right, so the 10% rule passes, so we go and end up getting a standard deviation of 0.008. So it looks something about like this. All right, oh, don't worry so much about 3. That was a little bit difficult. All right, 7.2. Now we're talking, right? This is what we're dealing with. So this is what we just talked about. We know if we take repeated samples of size n from a population proportion of interest p, the sampling distribution of p hat will have the following characteristics. The shape of the sampling distribution of p hat will be approximately normal as long as n times p is greater or equal to 10 and n times 1 minus p is greater or equal to 10. The mean of the sampling distribution p hat is mean of p hat equals p. It's an unbiased estimator of the population proportion. Standard deviation of p hat is standard deviation of p hat equals the square root of p times 1 minus p over n. And before you do this, you must show that it passes the 10% condition. So that's what it says right here. The formula with the standard deviation is exactly correct only if we're sampling from an infinite population or with replacement. When we're sampling without replacement from a finite population, the formula is approximately correct as long as the 10% condition is passed. So usually we are sampling from a finite population, so we have to check the 10% condition. That is, the sample size must be less than or equal to 10% of the population size. All right, so let's take a look here. All right, suppose that your job at a potato chip factory is to check each shipment of potatoes for quality assurance. Furthermore, suppose that a truckload of potatoes contain 95% that are acceptable for processing. If more than 10% are found to be unacceptable in a random sample, you have to reject the shipment. To check, you randomly select and test 250 potatoes. So I'm just going to write some notes here. My n size is 250. P hat is the sample proportion of unacceptable potatoes. Okay, so no problem. So it looks like that my P is actually going to be is the proportion of acceptable potatoes. The true proportion of acceptable potatoes. All right, so that's going to be, if 95% is unacceptable, then right here my P is going to be 0.05. Those are the ones that are acceptable, all right? So we want to know what is the mean of the sampling distribution of P hat. So that's right here. They're going to say mean of P hat is going to is an unbiased estimator of P, which we already said is 0.05. Okay? Check the 10% condition and calculate the standard deviation of the sampling distribution of P hat. So that's right here. We're going to figure out the standard deviation of the sampling distribution of P hat. And that formula, if you recall, is the square root of P times Q, which was 1 minus P, all over N. But we have to check the 10% condition first. That means N has to be less than 10% of the population. All right, so N is 250. Is that less than 10% of big N? Remember, we're talking about a number of a shipment of potatoes. Is that less than 10% of the full shipment of potatoes? Froze. Oh, here we go. Hang on one second, guys. Sorry, a little technical difficulty. Here we go. So is 250 less than 10% of the full shipment of potatoes? We're going to say yes. 250 is less than 0.10 times the full shipment. All right, the full shipment could be thousands and thousands of potatoes. All right, so we can go and get the standard deviation. So that's going to be, we know right here, 0.05. Times 1 minus p is 0.95 over n, which we said is 250. All right, so that's going to give us 0.0137. Remember, it didn't say to interpret this, but the interpretation of the standard deviation of a sample proportion is the typical distance of their sample proportion to the true of each sample proportion to the true proportion is what this is. This measures the typical distance of each sample proportion to the true proportion. All right, so check the normal condition and sketch the sampling distribution of p hat. Based on the sketch, do you think it would be likely to reject the truckload based on a random sample of 250 potatoes? Why or why not? Okay, so the normal condition right here, they're talking about large counts, right? So we're going to say np greater than or equal to 10. n1 minus p greater than or equal to 10. All right, so n once again is right here 250. P is, just rewrite this, P is 0.05. All right, so 250 times 0.05 ends up being 12.5, and that is greater or equal to 10. Check. So this is 250 times 1 minus P is 0.95. That ends up being 237.5, and that also is greater or equal to 10. So what does that mean? That means that we can assume the sampling distribution of p hat is approximately normal. Okay, so no problem. Let's go and draw a, so we're trying to find out right here, what are we trying to find out? Do you think it would be likely to reject the truckload based on the sample? So right here, all right, so what does it say right here? It says that right here, if more than 10% are found to be unacceptable at a random sample, you must reject the shipment right here. All right, so we're trying to figure out if it's, we're trying to find out the probability that more than 10%, X is greater than 10% of right here, of this truckload right here. And actually it's not X, my fault, it's, we're talking about right here a sample proportion. The probability that sample proportion is greater than 0.10. So we're going to go and draw our little curve right here. I'm going to do this on the side if you don't mind. All right, so once again, we had a .05 was our mean, and our standard deviation was 0.0137. Okay, no problem. So let's do it. So right here, we know our mean is 0.05. One standard deviation above is 0.0637. 0.05 minus 0.0137 ends up being 0.0363. Okay, so we want to try to figure out, once again, the probability that the sample proportion is greater than 0.10. So if you look right here, 0.10 will be like way up there. Okay, so we would just go and do normal CDF. Lower is 0.10, upper is 10,000, mean is 0.05, and the standard deviation is 0.0137. We end up getting 0.000131. All right, so a really small probability. So right here, they want to know, do you think it will be likely to reject the truckload based on the random sample of 250 potatoes? All right, so in this case right here, the probability of it being 10% or more is almost zero. So since there's almost no chance right here, and we had right here that the probability was 0.000131. of we have 10% or more being unacceptable, we are not going to reject the truckload. It would not be likely to reject the truckload. There's almost no chance of that happening. All right, that's it. Okay, going on to the next one. Let's see what we have here. Concept 2. Phone company of interest is exploring marketing possibilities for a new smartphone for teenagers. They ask a simple random sample of 1,000 high school students whether they own a smartphone. I'm just going to highlight that, or you can underline it because I know I'm going to need that later. Suppose 65% of all high school students own a smartphone. Right, so that's my population actually, 65% population parameter. What is the probability that the random sample selected by the company will result in a value of p hat that is within 3 percentage points of the true population proportion? So they're asking right here, what is the probability that a random sample selected by the company will result in a p hat value that is within 3 percentage points of the true population proportion? Show all your work. All right, so first of all, we have to see, is it approximately normal? Is the sampling distribution approximately normal? All right, so let's do it. We're going to do that. We'll do the large count condition, np greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So right here we know that n equals 1,000, my p equals 0.65, right? So we're going to say 1,000 times 0.65, which is going to end up being 650, greater or equal to 10, check. And this will be 1,000 times 0.35. That's going to be 350, greater or equal to 10. So we can say right here, the sampling distribution p hat is approximately normal. Okay, good. So no problem. Now at this point we'll go and get the mean and the standard deviation. Okay, so the mean of the sampling distribution is easy. That's an unbiased estimator of the regular, the true proportion. So that's going to just end up being 0.65. Now remember, we have to check the 10% condition to get the standard deviation. So we have to see, is 1,000 less than 10% of, now what are we talking about right here? We're talking about high school students right here. Okay, is 1,000 less than 10% of all high school students? Yes. If you notice, this 10% condition almost always passes. Oops, sorry. So it's yes. All right, so it passed right here. So we'll go ahead and get the standard deviation now of the sampling distribution. So that's going to be p times 1 minus p over n. That ends up being right here. P is 0.65. 1 minus p is 0.35. And n is, n was 1,000. Hang on a second. Let me do this over here so you can see this better. All right, that ends up being, when we calculate that, 0.015. Okay, no problem. Now, we're going to go and figure out the problem. So it says right here, what is the probability that the random sample selected by the company result in a p hat within 3 percentage points of the true proportion? Okay, so the probability right here, we're trying to figure out that it has a p hat within 3 percentage points of the true proportion. True proportion is 0.65. All right, within 3. So let's see here. So that's 3 greater than that is going to be 0.68. And 3 less than 0.65 is 0.62. So that's what we're trying to figure out right here. So let's go ahead and draw. 0.65 is the mean. Standard deviation is 0.015. So that's going to be 0.665 right here. If you add 0.015 and subtract 0.015, it's going to be 0.635. All right, so we're trying to figure out from 0.6 to probably from 0.62 to 0.68 within 3 percentage points, right? All right. So right here. So we're trying to figure out, remember, within 3 percentage points of the true population proportion. Okay, so let's take a look right here. So we're going to go shade that all in. All right, so that will be on your calculator. Remember, normal CDF, lower is 0.62, upper is 0.68, mean is 0.65, standard deviation is 0.015. All right, and that comes out to, let's do that. Okay, we'll go to second distribution, normal CDF, enter. So we're going to say right here our lower is 0.62, my upper is 0.68, my mean is 0.65, and my standard D is 0.015. Enter, enter, enter. There we go, 0.9545 if I round it, 0.9545. That's it. So the probability right here that it's within 3 percentage points is 0.9545. 3 percentage points of the population proportion. Okay? Probably that the sample proportion is within 3 percentage points of the population proportion is right there, 0.9545. Okay. So let's see here. For concept 3, I'll talk about later, okay?